Hello, today we will be talking about the car engine, its basic parts, and the working mechanism or the working process behind the car engine. So to begin with an introduction, car engines vary in design, but there are certain elements that will be common to all engines and hence can be used to study and classify the engine. For instance, you have the number of cylinders that can range from 2 to 12. You have 2 in scooters and in some bikes, and you have 12 in big vehicles. The geometry of the block and the type of ignition system used, that is whether it's spark ignition or it's auto ignition. All engines run on fuel. These fuels are made of petroleum or also known as crude oil. Both petrol and diesel come under this. There is a difference between petrol engine and diesel engine which we'll explain later down the video. How an engine looks like. So in front of you, you can see a schematic of the engine. There are different parts visible to you. For instance, the spark plug, exhaust cam, exhaust valve, clutch, gearbox, flywheel, crank, the piston, intake valve, intake cam. We will be describing in detail the functions of each of these parts. Before we start with the working process, I would like to show you the timeline of how the engines have progressed over the years. We began with steam power engines long back in 1801. After that, we progressed to coal gas engine, then the IC engine or the internal combustion engine, and later we came to electric ignition. In the past 15-20 years, we have also made huge progress towards the green design or the hybrid eco-friendly engines. So now we'll start with the working process. Car engines are built around a set of cooking pots. Why do we call these cooking pots? Is basically they cook the food which acts as the fuel of the engine. Without this fuel or the cooked food, the engine cannot run. So the cooking pot are basically the cylinders which have the pistons inside them. Inside these cylinders, the fuel burns. The cylinders have to be made of very strong metal and sealed shut because the processes inside them take place at high pressure. There are also tight-fitting pistons that can slide up and down inside them. At the top of each cylinder, there are 2 valves. So one is the inlet valve, which allows fuel and air to enter the cylinder from a carburetor or electronic fuel injector, and then there's the outlet valve that lets the exhaust gases escape. At the top of the cylinder, there is also a sparking plug, an electrically controlled device that makes a spark to set fire to the fuel. Remember, we talked about different types of ignitions. So this type of ignition will be called spark ignition. At the bottom of the cylinder, the piston is attached to a constantly turning axle known as the crankshaft. The crankshaft is what powers the car's gearbox, which in turn drives the wheels. This is basically the crux. These 4 processes constitute the whole burning process or the mechanism. So you have 4 strokes: the intake stroke, the compression stroke, the power stroke, and the exhaust stroke. Intake stroke is what takes the air-fuel mixture in. Compression is what compresses that mixture. Power stroke is what releases the power. And exhaust stroke is what releases the leftover exhaust gas mixture. So this is a diagram of the 4-stroke cycle where we have shown the intake stroke, the compression stroke, the combustion stroke, and the exhaust stroke. Each of the stroke is similar in the fact that it involves the movement of the piston. There are 2 different positions of the piston known as bottom dead center and top dead center. So each of the stroke can be defined by 2 things. A, the velocity, the direction of the velocity of the piston, and B, the initial and final position. That is whether it started from top dead center or bottom dead center, and whether it ended at bottom dead center or top dead center. So these few parameters can be used to describe the stroke. Each stroke is responsible for different things. So here we have added a video which we'll prefer to show towards the end. First, we'll talk about the different parts. For instance, you have to begin with, the fundamental building block is your engine head. Engine head is casted in the same way as the engine block. Its mold is made such that the casted piece must have an opening for air to flow into engine cylinder. Remember, we talked about how the air-fuel mixture is taken in through the intake stroke. This is from where the air enters. It also has an exhaust opening because, when the exhaust stroke is being performed, the exhaust gases need to be removed from the system. This passage of air flowing in and going out of engine cylinder is controlled by inlet and outlet valves. Next we come to the camshaft. So this is how a camshaft looks like. It is a shaft with a number of cam profiles along its length. It regulates the valve's opening and closing time. It does so by pressing the end of valve stem by its cam profile. So it is basically responsible for the different firing order of the pistons. Next we come to piston and piston rings. So as I have already described what a piston is that metallic block that slides up and down the cylinder. Piston rings are the small rings present inside the piston. They have a certain important function. For instance, the piston ring is responsible for preventing the fuel air mixture and exhaust in the combustion chamber from leaking. Also, they keep oil in the sump from leaking into the combustion area, which could otherwise prove to be very dangerous. Next, we come to the spark plug. A spark plug, this is what it looks like. It's actually very small in size. It is responsible for delivering electric current from an ignition system to the combustion chamber to ignite the compressed fuel air mixture. That is, the spark plug is responsible for the air fuel mixture to burn. This is the type of ignition. This type of ignition is known as spark ignition. So there are more parts which we'll like to discuss. So next we come to flywheel. The flywheel is, this is what the flywheel looks like. It is a large wheel. The main objective of the flywheel is to effectively store rotational energy. How it can do that is because it has a large moment of inertia. So, and flywheels resist change in their rotational speed by their moment of inertia. The amount of energy stored will be proportional to the square of rotational speed. Thus, they provide a path to store the energy and to provide stability to the system. Now we come to the cooling system. This is how the cooling system looks like. So the red is what is represented by the hot liquid, and the blue is what represents the cool liquid. Internal combustion engines must maintain a stable operating temperature, not too hot and not too cold. For this, the cooling system is present. With the massive amounts of heat that is generated from the combustion process, if the engine did not have a method for cooling itself, it would quickly self-destruct. So while some engines are air-cooled, the vast majority of engines are liquid-cooled. The water pump circulates coolant throughout the engine, hitting the hot areas around the cylinders and heads, and then sends the hot coolant to the radiator to be cooled off. Next we come to the dynamo. So this is a diagram that shows the alternator, which is an advanced form or the alternative to the previously used dynamos. However, the basic function for both is almost the same. Dynamos or generators convert mechanical rotation into electrical power. Dynamo is a device that makes direct current electric power using electromagnetism. It is also known as a generator. However, the term generator nowadays usually refers to as an alternator, as it is shown in the diagram, which creates alternating current power. Alternators are what are used in modern automobiles to charge the battery. Next, we come to the oil filter. The oil filter, this is how the oil filter looks like. This is an enlarged image of the oil filter. The oil filter is actually much smaller in size. The oil filter helps remove contaminants from the car engine's oil that can accumulate over the time and can thus damage the car engine. Hence, the oil filter is a very crucial component for the steady and longevity of the car engine. Next, we come to the serpentine belt. A serpentine belt, which is also commonly sometimes known as a multi-V, poly-V or a multi-rim belt. It is a single continuous belt, as it can be shown by this blue thin strip. So it is a continuous belt that passes over multiple peripheral devices in this car engine. So what it does is basically it links or connects all of these wheels such that the tangential velocity here also you can see the serpentine belt. So it connects them in such a way that the tangential velocity at the serpentine belt and at the edge of the circular moving part is the same. And hence, in a way, it links or couples different moving devices. This is important when we consider transmission system. Next, so towards the end, we come to the difference between petrol and diesel. So petrol and diesel, the basic difference between a petrol and diesel engine. Here we have shown a diagram that represents the difference. For instance, the price, the pollutants, the CO2 contamination, the engine lifespan, and the parking fees. But the basic difference between a diesel and petrol internal combustion engine, aside from the types of fuels they use, is how they ignite the fuel. A petrol engine uses a spark plug to ignite the fuel inside the cylinder, while a diesel engine uses a much higher compression ratio within the cylinder to heat the air inside. So there are other things which we have not discussed, such as the transmission system, because they would need a different video to discuss. However, we will now show the video or the animation of how the engine actually works. So this is the working. So for instance, here you can see this is the rotation of the crankshaft, which is causing the pistons to move up and down along the cylinders. As you could see, the pistons, not all four of them move together. This is what is the basic concept when we study the firing order. The different firing order is responsible for the stability and efficient power transmission of the system. So this is it for today.